be studying a new topic called circular motion. So this is also a subtopic of motion in two dimensions. And we'll be learning specially about we'll be learning two kinds of circular motion. One is called uniform circular motion and one is non-uniform circular motion. And I'll tell you what uniform and non-uniform circular motion are. Okay. Now before that we need to understand few things and few parameters in circular motion. Now before going into circular motion, I want to ask you one thing. Is velocity a vector or scalar?
Vector, sir.
So velocity is a vector. So the change in velocity can be done. The change in velocity can be a result of what? Change in velocity can be, yeah, it is acceleration, but my question is the change in velocity can be a result of either change in vector has two things, right? Two parameters are required to give the information about vector. So,
Sir, distance and direction.
yeah, the change in velocity can be a result of change in its magnitude,
direction,
or change in its direction, or what? Both, right?
Yes, sir.
Or both. Example. Initial velocity, or let me write it like this: u bar is equal to 3 I cap meters per second. 3 I cap meters per second. V bar equals to 5 I cap meters per second. Delta T. What is delta T? Time between these two.
Velocity.
10 seconds. So what is acceleration?
5 minus 3 by 10.
5 I cap minus 3 I cap divided by 10 units. Meter per second square. So tell me, what is acceleration?
1 by 5.
1 by 5 I cap.
1 by 5 I cap meters per second square. Now here this acceleration is a result of change in magnitude. Do you agree? Okay. So this is example 1. Example 2. U bar equals to 3 I cap. V bar equals to 3 J cap. Now, can you see one thing here? Delta t is again 10 seconds. Now, let me give the units meters per second. Meters per second. Now, can you see that magnitude is not changing? Only direction is changing. Clear? So, what is
Yes,
acceleration?
sir.
Final velocity
3
minus
by 10 minus 3
initial
by
velocity
10.
divided by
10.
delta t. Okay, which is equal to what?
3 j cap minus 3 I cap divided by 10.
By 10. If you write the units are meters per second square. Okay, so here I can write a bar equals to 3 by 10 I cap minus 3 by 10 j cap, and if I write units, it is meters per second square. Now this acceleration is the result of what? This acceleration is the result of change in direction. Magnitude is not changing here. Clear?
Yes.
Okay. So here, this is the result of change in magnitude only. This is the result of what?
Change in direction only.
Change in direction only. Okay, one second. Okay. Direction only. And there can be possibility when both the direction and magnitude change. Both the direction and magnitude change also. Clear?
Yes, sir.
Yes.
I'll give you that example. So you'll get all the cases. So suppose U bar is 3 I cap and V bar is 5 J cap. V bar is 5 J cap. And time is anything. You can take anything time. So let us take delta t as anything. Let us take it as 2 seconds. So what will be the acceleration?
5 j cap minus 3 I cap
5
divided.
J cap minus 3 I cap divided by 2. So I'm writing the units here. So let it be meters per second. Here, this is also meters per second. So this will be in meters per second square. So tell me what is acceleration?
5 by 2 j cap minus 3 by 2 I cap.
Minus 3 by 2 I cap plus 5 by 2 J cap. Meters per second square. Now this acceleration is a result of what? It's a result of
Change
both change in both direction and magnitude. Okay. Now there are certain things that are confusing. Just in definition. The definition itself are confusing. The confusion is this: when you see, when motion is in straight line, for motion in a straight line, the other name for motion in a straight line is linear motion. One more name is translatory motion. You have to remember this. So motion in a straight line is also called linear motion and translatory motion. Okay.
Yes,
So the first chapter, or it is also called motion in
One dimension.
one dimension. When you are talking about linear motion, when you say uniform, what does that mean? Uniform implies constant acceleration. Okay. Clear? Uniform implies constant acceleration. Even in 2D, even in projectile motion. Projectile motion. Is projectile motion uniform or non-uniform?
uniform.
It is uniform motion. It is also uniform motion. Reason?
Because acceleration is constant.
Okay, I think there is some problem. So this is also uniform motion. Why? Projectile motion is uniform motion. Why?
Acceleration is constant.
Acceleration is constant. Since acceleration is constant. Now, when you say acceleration is constant, both direction and magnitude magnitude of acceleration must be constant, or should not change. That is, should not change. And for projectile motion, acceleration is always g downwards, right? Do you agree?
Yeah.
So the magnitude is g and it is downwards. 1 second. So because the acceleration is g and it is always downwards, what can we say? It is uniform motion. Do you agree? Okay. Clear?
Hmm.
Okay. Now, so this is for linear motion. When you are talking about linear motion, we say that uniform means acceleration is constant, and non-uniform means. So what is non-uniform? If A is
not constant.
variable. Clear? Okay. So these are all the definitions for translatory motion, or when we are talking about linear acceleration, linear velocity, etc., etc. These are all the definitions of uniform and non-uniform. Clear? Okay. So this is the thing. No, but circular motion is different. Okay, let me explain. In circular motion, let me just first introduce what circular motion is. Okay, so this is a circular path. This is a circular path. Okay, this is a circular path. So let us just draw Cartesian coordinates for reference. So this is x-axis and this is y-axis. Okay. And the particle is suppose moving in anti-clockwise direction. So I'll draw that. So let us draw it here. Okay. So the body is moving in anti-clockwise direction. Okay. Let the radius of this circle be r. Let the radius of this circle be r. So I'm drawing that. Okay, we'll draw it here. I don't know what is happening. The radius is r. And there are two kinds of circular motions. So for circular motion, what is the condition? For circular motion, what is the condition?
So displacement should be 0.
No. It should move on the circular path. Okay.
Yes.
So for circular motion, it should move on. Okay, let me. The particle must move on. Move along a circle. Okay. Now, first thing is very clear that in circular motion, is velocity constant?
No, sir.
Velocity in circular motion cannot be constant. Cannot be constant. Why?
Because it is direction change.
So velocity v bar cannot be constant. I should write here. Because the direction is changing, right? Its direction is changing. Now, can the speed be constant?
Yes, sir.
Can the speed be constant? Answer is yes.
Yes.
And moreover, if the speed is constant, it's uniform circular motion. Uniform circular motion. If the speed is variable, it's non-uniform circular motion. Non-uniform circular motion. So are you understanding one thing here? Last time uniform and non-uniform was defined based on acceleration, but here uniform and non-uniform is defined based on speed. Clear? Okay?
Yes.
Okay, so that is the big difference you have to remember in the definition of uniform circular motion, non-uniform circular motion, and uniform motion and non-uniform motion. Okay, when I say uniform motion and non-uniform motion in one-dimensional or two-dimensional motion or projectile motion, there or when you are talking about linear acceleration, there the definition is different. Here the definition is different. Clear? Okay.
Yes, sir.
So that is the most important thing. Now let us go into some definitions now. So okay, let us go into some definitions now. See, now initially suppose the particle is here. Okay, finally suppose the particle is here. So this is initial position, this is final position. Are you getting that? This is initial position and this is final position. Okay. The angle made by so this is the angle that the particle has covered. Are you getting? This is the angle that the particle has covered, going from initial position to final position. Okay, so let me call it theta. Let me call it theta. Or let me take a small angle d theta. Let me take a small angle d theta. Tell me what is d theta? What does d theta mean? What does d theta mean? That this it has traveled a very small distance. Let the time taken for the particle to go from here to here be dt. Let it be dt. So can you see? Okay. Let me take another color. Okay. So the particle is going from here to here, right? So I think there is. Okay. Now, if this d theta is very small, this line will almost be a straight line. Do you agree? This dl will almost be a straight line. I'm not drawing very small because you cannot see, but if it is very small, you imagine it will be a straight line. Do you agree? Are you getting my point?
Yes, sir.
I'm writing it here. If d theta is small, dl will almost be a straight line. Will almost be a straight line. Okay. Now, if the radius of this circle is r, can you tell me what is the relationship between r, d theta and dl? If the radius of this circle is r, can you tell me what is the relationship between r, d theta and dl?
So d theta equals to dl by r.
Very good. D theta equal to dl by r. How do you know that?
So
Definition of dl by r. This is the definition of what? Angle, right?
yes, sir.
Angle is arc length by radius. This angle is arc length divided by radius. We have seen that in the first chapter, basic mathematics, right? So, do you agree? D theta is equal to dl by r. Okay.
Yes, sir.
D theta equals to dl by r. D theta equals to dl by r. Okay. Now, if the particle has, if the speed of the particle is uniformly increasing, are you getting my point? If the speed of the particle is uniformly increasing, then what is the situation? Let us see. Okay, before that, let me define one thing. What is dl equal to?
D theta into r.
Okay, dl equals to r d theta. dl equals to r d theta. Okay, dl equals to r d theta. Now, if I divide it by dt on both sides, what do you get? dl by
dt.
dt equals to r d theta by dt. What is dl by dt? Tell me. dl by dt.
Speed.
It will be speed. It will be speed, or it will be velocity also. It will be instantaneous velocity. Do you agree?
Yes, sir.
So dl by dt is instantaneous velocity. So can I write it as v equals to r d theta by dt is omega. Omega is called angular velocity. It is called angular velocity. What is it called? Angular velocity. Okay. Are you getting my point? What is angular velocity?
D theta by dt.
No, by definition. Rate of change of
Theta.
angular displacement. Angular displacement. What is theta? What is d theta? This is angular displacement. Okay.
Yes, sir.
Okay. Now that means when you are saying angular displacement and angular velocity, this must have direction also. I'll discuss about the directions later. Okay, I'll discuss about the directions later. Actually, the directions are given by right hand thumb rule. Now here, for this particle, the direction of d theta is above the out of the plane. Are you getting my point? Why? Because if you put your fingers in the direction of displacement of particle, your thumb will point out of the plane. Clear? Okay? And angular velocity will also be out of the plane. Are you getting my point? If you put your fingers in this direction, your thumb will point upward, right? Your fingers will be in this direction and your thumb will point upward. Are you getting my point? Because the particle is moving like this. If you put your fingers in this direction, your thumb will point upward, right hand thumb rule. Clear?
Yes, sir.
So the direction of d theta is up the plane, direction of omega is also up the plane. Clear? We'll just come to that later. Okay, so angular velocity is rate of change of angular displacement. Now, if I use this expression v equals to r omega, and differentiate it on both sides. What do I get? Or take the derivative on both sides. Take the derivative with respect to t. On both sides. What do I get? Tell me.
Sir, acceleration
Yeah. So first tell the expression. dv by dt.
equals to drw by dt.
dv by dt is equal to r is a constant, right? Even if the particle is moving on circle, r doesn't change. So r will come outside into d omega by dt. d omega by dt. Clear? So what is dv by dt? Tell me.
Acceleration.
Linear acceleration, because it is rate of change of linear velocity. And what is d omega by dt? It is angular acceleration, and it is represented by alpha. Clear? So I'm just mentioning it. Alpha is what? Alpha is what? I don't know what is happening. What is this? This is
Angular velocity.
angular acceleration. So direction of the angular acceleration will depend on omega. If omega is increasing, it will be upwards, up the plane. If omega is decreasing, it will be down the plane. Clear? Okay. So 3 new expressions you got here. What are those? Tell me. D theta. Tell me.
Theta equals to V by R.
Or dl equals to r d theta. dl equals to r d theta. Second one is v is equal to r omega. Third one is a is equal to r alpha. Agreed? Okay. Okay. Or what are the alternate versions of this? Alternate versions. D theta equals to
dl
dl by r. Omega equals to
V
velocity.
by
v by r. And alpha equals to
E
a
by
by r. Now these are very important relationships, and these relationships you will be using a lot in this chapter as well as in the chapter called rotational dynamics. Okay, so you have to be very familiar with these three relationships. Okay, extremely important. Okay, tell me what are the units of d theta?
The radian.
Radians. What are the units of omega? Radians per second. Clear? What are the units of alpha?
Radians per second square.
Radians per second square. Clear? Okay?
Yes.
Okay, fine. So these are the units which you have to remember. Now basically radian is what? Radian is radian is the unit of angle, but in reality the angle is dimensionless, right? Angle is dimensionless. Are you getting my point? Are you getting my point?
Yes, sir.
उसका यूनिट रेडियन है बट वो एक्चुअली डायमेंशनलेस है, उसका कोई यूनिट नहीं है. ठीक है. सो इफ यू सी डीएल, इट्स का मीटर है, इसका भी मीटर है. मीटर बाय मीटर इज डायमेंशनलेस. दिस इज मीटर पर सेकेंड, दिस इज मीटर कैंसल एंड इट विल बी जस्ट पर सेकेंड. This will be meter per second square. This is meter, meter, meter cancel, and it will be just per second square. That's all. Radians is dimensionless thing. Okay. Okay, fine. Now, if alpha is 0, now just pay attention. If alpha is 0, if alpha is 0, then it's uniform circular motion. Are you getting? Do you agree? If omega is constant, then it's uniform circular motion. Do you agree?
Yes.
If next statement, is this true? If v is constant, then it's uniform circular motion.
Yes.
Is it correct or wrong? Is the statement correct or wrong? If v is constant, it's uniform circular motion. Is the statement correct or wrong?
Sir,
So
wrong.
wrong.
Wrong. Why?
So because velocity's direction always changes. So it must
Velocity cannot be constant in circular motion, because if velocity is constant, both its magnitude and direction must not change. But in circular motion, it must change its direction, right? So what is the correct statement here? If,
It is
yeah, tell me.
speed is constant.
Speed is constant, or if the magnitude of, do you agree? Of v is constant. Are you getting my point?
Yes, sir.
Now is it correct?
Yes.
Now it is correct. Then it's uniform circular motion. Are you getting my point? Okay, clear? Okay, now tell me, if alpha is constant, but non-zero, then the circular motion is non-uniform. Do you agree? Do you agree?
Yes, sir.
If alpha is variable, then the uh, circular motion is again non-uniform only. Do you agree? अल्फा कांस्टेंट है, नॉन जीरो है तो भी नॉन यूनिफॉर्म मोशन है, अल्फा वेरिएबल है फिर भी नॉन यूनिफॉर्म सर्कुलर मोशन है. क्लियर?
जी सर.
So there are two kinds of, or there will be two subcategories of non-uniform circular motion. One is where alpha is constant but non-zero. Second is when alpha is variable. Clear? Okay. Now, in case of non-uniform circular motion, when alpha is constant, there are two things. The magnitude of A is constant. Do you agree? है कि नहीं? Why? A is equal to R alpha. समझ में आई बात?
Yes, sir.
ये कांस्टेंट है तो ये भी कांस्टेंट हो जाएगा. क्लियर?
Yes, sir.
है कि नहीं? क्लियर? Okay. A is constant. So equations of motions are applicable. Therefore, equations of motion कब applicable होगा?
सर जब एक्सेलरेशन कांस्टेंट हो.
Equations of motion are applicable. A की वैल्यू जब कांस्टेंट होती है तो v इक्वल टू u प्लस ए टी, एस इक्वल टू यू टी प्लस हाफ ए टी स्क्वायर एंड वी स्क्वायर माइनस यू स्क्वायर इज इक्वल टू 2as. वो जो है ना एप्लीकेबल है. ठीक है, समझ में आई बात? ओके. नाउ टेल मी, v इक्वल्स टू u प्लस ए टी कैसे लिखेंगे? v इक्वल्स टू u प्लस ए टी को कैन यू डिवाइड r? तो क्या हो गया? v बाई आर इक्वल्स टू u बाई आर प्लस a बाई आर into t. Is it correct? Are you getting my point?
Yes, sir.
What did we do? We divided by r. So what did we get? What is v by r? Is omega. U by r is omega naught. A by r is alpha. T is t. You got it?
Yes, sir.
तो यहाँ पे ओमेगा क्या है? बोलो. ओमेगा क्या है?
Final angular displacement.
Final omega is final angular velocity. ओमेगा नॉट क्या है? इनिशियल
Angular velocity.
एंगुलर वेलोसिटी. और अल्फा क्या है? एंगुलर एक्सेलरेशन. क्लियर? ओके, क्लियर.
Yes,
What
sir.
about this? S equals to ut plus half at square. S की जगह क्या लिखेंगे हम लोग? ds लिख लेंगे, चलेगा? So I'm just changing it. ds equals to ut plus half at square. ds में dl लिखते हैं, ठीक है? dl. No. Or let us keep s only. Let us keep it as s only. Okay. Now what do? We divide by r. If we divide by r, what will we get? Tell me. S by r, u by r, a by r. Clear?
Yes, sir.
समझ में आया? तो I think I'll tell you there is one small thing that you need to keep in mind here. S must be small. S must be ये मतलब स्मॉल टाइम इंटरवल के लिए एप्लीकेबल है. समझ में आया? देखो मैं बताऊंगा. इधर से इधर अगर जाएगा तो डिस्टेंस ट्रैवल्ड एंड डिस्टेंस अलग अलग हो जाएगा. डू यू एग्री?
Yes, sir.
क्लियर? बट अगर इधर से इधर ट्रैवल करेगा तो दोनों सेम रहेंगे, राइट?
जी sir.
So this is applicable, this equation derivation is applicable by for small time interval only. For small time interval dt, t must be small, t must be small, dl must be small. Clear? Okay.
Yes, sir.
So what will this be? What is s by r? S by r is theta because it is l by r, right?
Yes, sir.
U by r is omega naught plus half alpha t square. Now this is very easy to remember if you think. See, this equation is just analogous to s equal to ut plus half at square. Are you getting my point? Okay.
Yes.
So v is equal to u plus at के बदले आएगा ओमेगा is equal to omega naught plus alpha t. और s equal to ut plus half at square के बदले आएगा theta equals to omega naught t plus half alpha t square. Clear? What about third equation? Third equation क्या है? v square minus u square equals to 2as. Clear? Now we have to divide by r square on both sides. Divide by r square on both sides. यहाँ पे क्या क्या? Divide by r on both sides. So what do you get here? Tell me. V by r whole square minus u by r whole square equals to 2a by r. Tell me. Into s by r. So what is the conclusion here?
Omega square
Omega square
minus omega naught square.
omega naught square equals to 2 alpha theta. 2 alpha theta. Clear? Okay. Yeah.
Sir, आपने divided by r square लिखा हुआ था.
हाँ
on both sides तो नहीं किया।
हाँ, इधर भी आर स्क्वायर है ना, आर स्क्वायर है, इधर भी आर स्क्वायर है, इधर ये दो मिला के आर स्क्वायर है, ठीक है, क्लियर?
Yes, sir. Yes.
So we got three equations. Equations for non-uniform circular motion. Non-uniform circular motion when alpha is constant. Alpha is constant. समझ में आया? और एक है non-uniform circular motion. Okay. The above equations are not valid. Above equations are valid only if alpha is constant. Clear? Not valid if invalid. If alpha is
Zero.
variable. Clear? Okay. So three equations for non-uniform circular motion when alpha is constant are very easy to remember. Just like V equals to U plus AT. V equals to U plus AT के बदले क्या है? Omega equals to omega naught plus alpha t. Second, S equal to UT plus half AT square के बदले क्या आएगा? Theta equals to omega naught t plus half
अल्फा टी स्क्वायर।
alpha t square. और V square minus U square is equal to 2as के बदले क्या आएगा?
ओमेगा स्क्वायर माइनस ओमेगा नॉट स्क्वायर।
Omega square minus omega naught square is equal to 2 into alpha into theta. Clear?
यस सर।
Very easy. These are same as, you know, three equations of motion. Equations of motion. So no special thing is required to remember this. Clear?
यस सर।
Okay. So you have to remember this. So problems also will be exactly same. Some parameters will be given. He will ask you another unknown parameter. So whichever equation fits, you have to just use it. Now, just tell me, this is linear, angular, initial velocity, final velocity, displacement, what else? Acceleration. Tell me. बोलो लीनियर क्या है? एस यू वी ए. ये क्या है? थीटा ओमेगा नॉट
ओमेगा
ओमेगा
अल्फा।
अल्फा. ठीक है. और क्या है? एक चीज है जो दोनों में सेम है. एक पैरामीटर बदलेगा नहीं इसमें और उसमें, वो क्या है? टाइम। टाइम इधर भी टी रहेगा, इधर भी टी रहेगा, ठीक है। तो इक्वेशंस जो है ना, इक्वेशंस दे डोंट चेंज from one to the other. Equations will be same. Okay, equations will be same. V equals to u plus at का एग्जैक्टली उसके एंगुलर पैरामीटर्स आ जाएंगे। s इक्वल टू ut प्लस हाफ at स्क्वायर का एग्जैक्टली उसके एंगुलर पैरामीटर्स आ जाएंगे, और v स्क्वायर माइनस u स्क्वायर इज इक्वल टू 2s का उसके एंगुलर पैरामीटर्स आ जाएंगे। ठीक है, क्लियर? Now tell me one thing, is acceleration constant or variable in uniform circular motion? Tell me.
Variable.
Why?
So because direction is changing continuously.
Very good. Okay. I think okay, अभी ठीक है। तो suppose some particle is moving in circular motion. The acceleration will keep changing. The acceleration will keep changing because the direction of velocity is changing. You will understand in 1 minute. You will understand what about the acceleration of particle in uniform motion. You will understand. Wait. Now initially the particle is here. I am drawing this vector. Finally the particle is here. So let me just write down. Can I write it as initial position ri bar, and can I write it as final position rf bar? Any problem? Okay, is it correct?
Yes, sir.
Now initially, see, always the velocity will be tangential to the direction of tangential to the circle. Do you agree? वेलोसिटी हमेशा टेंजेंशियल होती है। टेंजेंशियल मतलब क्या? टेंजेंशियल मतलब क्या?
The tangent to a circle.
In the direction of tangent. In the direction of tangent. So these are the velocities: initial velocity and final velocity. Do you agree? समझ में आई बात? ये दोनों के बीच में जो एंगल है ना, दोनों के बीच में जो एंगल है वो एंगल थीटा है। ठीक है, किसके बीच में?
Ri bar.
इनिशियल पोजीशन और फाइनल पोजीशन के बीच में जो एंगल है वो क्या है? एंगल, let us take it as d theta. Let us take it as d theta. Are you getting my point? Okay, समझ में आई बात?
Yes, sir.
अब यहाँ पे एक चीज गौर करना, there are some vectors which cannot be slided, like position vectors को slide नहीं कर सकते आप। ठीक है, अच्छा ये क्या हो जाएगा? बोलो ये क्या हो जाएगा? What about this? Initial position to final position क्या आएगा आपको? Change in position आएगा। Agreed?
Yes, sir.
Can I write it as delta r? Delta means change, right? or can I write it as dr bar? What is change in position in physics?
Displacement.
Displacement. Very good. So I'm writing it as dr bar. Dr bar. So what is this dr bar? Displacement. Do you agree? देखो पार्टिकल पहले ए पे था फिर बी पे चले गया, ठीक है, पहले पॉइंट ए पे था फिर पॉइंट बी पे चले गया, तो ए बी क्या होगा? डिस्प्लेसमेंट होगा, है क्या नहीं? ये पॉइंट ए है, ये पॉइंट ओ है, ऑरिजिन पॉइंट ओ है, ये पॉइंट ए है और ये पॉइंट बी है. डू यू अग्री? तो इनिशियल और फाइनल पोजीशंस के बीच में जो डिस्टेंस है उसको डिस्प्लेसमेंट बोलते हैं, और इट इज व्हाट? टेल मी. आर एफ माइनस आर आई. डू यू अग्री?
Yes, sir.
So here dr bar equals to rf minus ri. Okay, so just leave it. Now if you look at velocities, velocity vectors, velocity vector दिखाई दिया आपको vi और vf? So can I draw velocity vectors like this? Let me just take this triangle. Watch carefully what I am doing here. I'm taking this as vi and I'm taking this as vf, and the angle between I'm taking as theta. Now the thing is, see, can you observe one thing? Why I have taken angle d theta here again? Why? Because see, the angle between position vectors is d theta, then the angle between velocities also should be d theta. Why? Because this is perpendicular to this and this is perpendicular to this. If angle between these is d theta, then angle between their perpendiculars must also be d theta. Are you getting my point? Okay.
Yes, sir.
इन दोनों के बीच में अगर एंगल डी थीटा है तो उनके परपेंडिकुलर्स के बीच में भी एंगल डी थीटा है, एंड वेलोसिटी वेक्टर को आप स्लाइड कर सकते हो, इसलिए मैंने इन दोनों के टेल्स एक जगह लगा दिए. क्लियर? ओके. नाउ टेल मी व्हाट इज दिस वेक्टर? व्हाट इज दिस वेक्टर? ये वेक्टर क्या है बोलो? ये वाला, ये ग्रीन कलर वाला, ये वेक्टर.
Sir, acceleration.
दिस इज चेंज इन वेलोसिटी dv. देखो जैसा r इनिशियल और i फाइनल के बीच में क्या आया? चेंज इन आ रहा है. v इनिशियल और v फाइनल के बीच में क्या आएगा? चेंज इन v आएगा. डू यू अग्री? change in velocity dv can be written as v final minus v initial. Do you agree? है क्या नहीं? Clear? Any doubt in this?
No, sir.
Okay. Now these two are similar triangles. Do you agree? Why? RF, magnitude of RF equals to magnitude of RI. R doesn't change ना, क्योंकि सर्कल पे है, is equal to R. Reason? R doesn't change. R doesn't change. Clear? Next. VF equals to VI. मैग्नीट्यूड की बात हो रही है यहाँ पे, ठीक है? ओके, इक्वल टू V, इक्वल टू V. Why? Tell me. रीजन बोलो. V क्यों चेंज नहीं हो रहा है यहाँ पे? V का मैग्नीट्यूड क्यों नहीं चेंज हो रहा? बोलो. Since, बोलो, it's uniform circular motion. ठीक है?
Yes.
What do you mean by uniform circular motion?
Whose speed doesn't change.
Speed doesn't change. So magnitude of velocity also doesn't change because magnitude of velocity is speed. Clear? है क्या नहीं? तो ये दोनों आइसोसीलस ट्रायंगल्स हो गए. ये दोनों क्या हो गए? आइसोसीलस ट्रायंगल्स. और दोनों का एंगल सेम है डी थीटा. इसका मतलब सिमिलर हो गए. क्लियर? आर यू गेटिंग माय पॉइंट?
Yes, sir.
Isosceles and similar. Since angle is same. Do you agree? है क्या नहीं?
Yes, sir.
So I'm redrawing these two triangles just for understanding. So let me just remove all this. Let me just remove all this. Okay. Okay, fine. Now if I want to write the magnitudes here, what will be the magnitudes? ये होगा dr, ये होगा r, ये होगा r, और ये होगा v, v, और ऊपर वाला क्या होगा? बोलो.
D.
dv. dv. क्लियर? समझ में आई बात? थोड़ा बड़ा कर दो. Now when you have two similar triangles, then the ratio of their corresponding sides are equal. Do you agree? है क्या नहीं? Must be equal for what? Similar triangles. Do you agree? तो बोलना क्या है? dr by r. बोलो. dr by r will be equal to dv by v. Do you agree?
Yes, sir.
है क्या नहीं? तो just rearrange that. What will you get?
V by R equals to D.
v dr or v by r, v by r dr equals to dv. Clear?
Yes, sir.
Now if I divide dt on both sides, divide on both sides by dt, we get what? बोलो. v by r dr by
DT.
dt equals to
dV
dv by dt. dv by dt क्या होगा?
acceleration.
मैग्नीट्यूड ऑफ एक्सेलरेशन होगा. क्या होगा? मैग्नीट्यूड ऑफ एक्सेलरेशन. है क्या नहीं?
Yes, sir.
a equals to what is dr by dt?
Mm,
डिस्प्लेसमेंट बाय टाइम, रेट ऑफ चेंज ऑफ डिस्प्लेसमेंट क्या होगा?
t velocity.
v होगा, है कि नहीं?
Yes sir.
ये होगा v, तो ये होगा v आपका रेट ऑफ चेंज ऑफ डिस्प्लेसमेंट। ठीक है, तो क्या हो गया बोलो, a क्या है आपको लास्ट में?
v square by r.
a इक्वल्स टू v स्क्वायर बाय r, v स्क्वायर बाय r। अच्छा, तो एक्सेलरेशन का मैग्नीट्यूड आ गया आपको v स्क्वायर बाय r। v square by r. Okay. Now if you look at this, I'm redrawing this. देखो copy. If you look at this, if you look at the direction of acceleration, देखो direction of acceleration अगर चाहिए आपको तो कैसे देंगे डायरेक्शन ऑफ एक्सेलरेशन? देखो इसको कॉपी करता हूँ, vi को कॉपी कर रहा हूँ मैं, देखो कॉपी पेस्ट, so let me just take it, see if I put, okay, vf को ऐसे लिख दो, vf को इधर लिख दिया, ये vi है, तो अगर स्लाइड कर दिया vi को, तो अगर थोड़ा करेक्ट मैंने ड्रॉ किया ये, तो इफ यू लुक एट द डायरेक्शन ऑफ dv, डायरेक्शन ऑफ dv किधर होगा? इधर होगा, देखो दिस इज द डायरेक्शन ऑफ dv, आर यू गेटिंग?
Yes.
if I draw it very correctly, और d थीटा अगर मैंने बहुत ही छोटा लिया और मैंने करेक्टली ड्रॉ किया, this will be pointing towards center, the direction of dv will be towards center, are you getting my point? ये dv
Yes, sir.
डायरेक्शन जो होगा वो सेंटर की तरफ होगा। Okay, this is dv. Let us change this color. Okay, dv का डायरेक्शन क्या होगा? सेंटर की तरफ होगा। समझ में आई बात? dv का डायरेक्शन देखो सेंटर की तरफ होगा, तो dv का डायरेक्शन अगर सेंटर की तरफ होगा तो a का डायरेक्शन भी सेंटर की तरफ होगा। इन यूनिफॉर्म सर्कुलर मोशन व्हाट, क्या बोलो? इन यूनिफॉर्म सर्कुलर मोशन dv always points
Towards center.
towards center, therefore a is also always towards center। ठीक है,
Yes sir.
a is therefore called what? क्या 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 बुलाते हैं को? बोलो।
Some
हाँ, a is therefore called what?
centripetal acceleration.
सेंट्रिपिटल एक्सेलरेशन, क्योंकि इट इज टुवर्ड्स सेंटर। ठीक है, a is also called radial acceleration, it is also called रेडियल एक्सेलरेशन. ठीक है. Why radial? Again, it is self-explanatory. Clear? Okay? समझ में आया? समझ में आई बात?
Yes, sir.
अच्छा, ये तो एक सिंपल डेरिवेशन है. दिस डेरिवेशन इज फॉर स्कूल. इन स्कूल यू लर्न दिस डेरिवेशन बाय यूजिंग सिमिलर ट्रायंगल्स. ओके. सेंट्रीपिटल एक्सेलरेशन क्या है? क्या है? मैग्नीट्यूड ऑफ सेंट्रीपिटल एक्सेलरेशन इज हाउ मच?
0.
V square by R. V square by
R.
R. So if centripetal acceleration is V square by R, if centripetal acceleration is V square by R, then what is the centripetal force required? बोलो.
Sir, can you repeat the question?
If centripetal acceleration is V square by R, then what is the centripetal force required?
M into V square by R.
Yes. Now here I can write therefore for a particle to be in circular motion, it must be under a force equal to how much? M into
V square by R.
B square by R. How do you know this? Because Newton's second law says F equals to ma. Okay. So
Yes, sir.
Newton F equals to ma. So if something has acceleration a, then the force acting on that particle is ma. So if m is the mass of the particle and its acceleration is v square by r, force acting on it must be mv square by r. This is also called centripetal force. Okay, this is also called centripetal force. Now for example, if planet is revolving around the sun, centripetal force is gravitational force between the planet and the sun. If electron is revolving in the atom around the nucleus, the centripetal force is due to the electrostatic force of attraction between positively charged nucleus and negatively charged electron. Clear? If a car is moving on a circular road, what is providing the centripetal force? Tell me. Huh? If a car is moving on the circular road, तो वो सर्कल पे जाने के लिए जो सेंट्रिपिटल फोर्स रिक्वायर्ड है, who is providing that?
Velocity.
No. Centripetal force, who is providing? Who is pulling the car towards center?
For center.
No. What is the force that is pulling the car towards center for it to go in circle?
Sir, mv square by R.
No. If a car is going in circle, हाँ बोलो.
Acceleration, sir.
No. If a car is moving in a circular road, tell me. If a car is moving in a circular road, I don't know what is happening. Who is providing the centripetal force? Tell me. Now this car is moving in the circular road. Who is providing the centripetal force? Centripetal force should be in which direction? Tell me. In this direction, right? Always in this direction. When the car is here, it must be here. When the car is here, it must be here. When the car is here, always it must be towards center. Now who is pulling this car towards center? Tell me.
Magnitude, sir.
Mm-hmm. What? Tell me. Center की तरफ only one and only one force is acting on car. Which is that? Who is pushing car towards center?
Centripetal force.
No. Centripetal force only. Who is giving that centripetal force? What is the physical form of that force? It is, think and tell. जब कार आप मोड़ते हो तो what is the reason for the car turning in circle? If you turn your steering.
The change in velocity.
No. It's frictional force. You must think and tell answer. Frictional force. Frictional force है इसीलिए सर्कल में टर्न किया. अगर फ्रिक्शनल फोर्स नहीं होता, suppose car is coming from here. Suppose car is coming from here. Okay, suddenly when he is entering this circular road, he is turning the steering, so the car is turning here. Are you getting my point?
Yes, sir.
Like, if there is no friction, for example, if it is ice fully, there is ice on road, there is no friction, and if I turn the steering, will the car turn?
No, sir.
No, it will just slip in the straight direction. कार ऐसे चले जाएगी, फ्रिक्शन नहीं होगा तो कार ऐसे चले जाएगी. ठीक है, समझ में आया?
Yes, sir.
So if there is no friction, this is the no friction. This is how the car will go. Are you getting my point? If there is friction or with friction, car will move in circular path. Clear? समझ में आई बात?
Yes, sir.
So just let me change. You'll understand. Okay. So this is the situation here. Clear? So for car moving on a circular road, who is providing the centripetal force? Frictional force between the tires and the road. Clear? Okay. Clear?
Yes, sir.
So tomorrow I'll give you one more derivation for this v square by r. It is the proper derivation. This derivation also you just make it perfect. Practice it. Tomorrow I'll give you another derivation. We'll use coordinate system and derive. Okay. So I'll share assignment for circular motion. You start looking at the problems. But today you cannot do much. From tomorrow you can start doing. Clear?
Yes, sir.
Okay. So I'm ending the lecture. Tomorrow we'll continue.
Thank you, sir.
Okay. Thank you.